Hello dear students, welcome to the course of Thermodynamics. Myself Mistry, Assistant Professor from Mechanical Department of LJIET Institute of Engineering and Technology. So today we are going to discuss about thermal properties. Heat and work. So first of all, temperature. So temperature is the quantity that will represent the degree of hotness or coldness of the system. We know that temperature generally is defined in three units: Kelvin, Celsius and Fahrenheit. So the relation between Kelvin and Celsius is this, and the relation between degree Celsius and degree Fahrenheit is this. Remember these two units or conversion, students. It will be helpful for converting the units. Okay. Now work transfer. So different types of work transfers are there. The very first is what? Displacement work or PDV. Simple. If a piston is reciprocating in a cylinder, then initially the value of pressure and volume will be P1 V1, and after certain time at location number 2 the value of pressure and volume will be P2 V2. So now we can write that the work done is equal to nothing but integration of PDV, that is from V1 to V2. And if I want to plot the graph, then for P versus V the graph will be like this. As you can see, at one particular position the value of pressure is different and the value of volume is different, and at particularly two position the value of pressure will be different and the value of volume will be different. Here you may observe, students, that if I find out the area below the curvature of the work done, then that area will give me the work done during the process. Here you may observe that the area which I have highlighted with the red lines, that area is nothing but the work done during the process 1 to 2. So always remember that when you will plot the graph of pressure versus volume, and if you plot any curvature on that graph, then the area under that curvature will give you the work done during that particular process. Okay. Now remember, students, that area is taken on the x-axis, that is on the volume axis. Okay. Now further consider and pay attention over here that if I will change the process path, let's say I will move from 1 to 2 following a different path like this, right? That is highlighted by red color. So now observe what will be the work done. Will it be same like the previous procedure, that is this path, or will it be different? So as you can see, I have already defined that the work done is defined by the area under the line drawn or curvature drawn. So in the second process, the area is increased. Here you can see by H portion I am defining it. So the area is increased in the second portion. So the work done has changed, though the initial point and the final point of the processes are same. Okay, the initial point and final point of the process are same, but the path are different. So work has changed. So the meaning is what? Meaning is simple. Work is dependent on the path. So it is called as path function. So what is path function? The function which is dependent on the path followed during the execution, that is called as path function. Okay. Heat is also path function and work is also path function. I hope you have understood from this diagram. Now flow work. Other type of work transfer is flow work, that is significantly open system. Flow work means what? Very simple. Then consider a motor or pipeline at your home, and through that pipeline, let's say the water is flowing. So how the water is flowing? You might have imparted some energy on the water to make it flow. So the energy imparted on the fluid to make it flow through the system, that is called as flow work. So for understanding, I have simply drawn a system over here, and in this system some mass is entering and some mass is leaving. Okay, and at, let's say, section 1 the pressure is P1, then velocity is V1, and area of the cross section is A. Same way at the outlet, that is 2, the value of pressure, velocity and area is P2, V2 and A2 respectively. Okay, so now I want to define the work. So you know that the work is what? Force into distance. Okay. So force is what? Force is nothing but pressure into area. So pressure into area, that is why P into A I have defined like this. Okay. P into A. Very easy to understand. Then I told you that work is nothing but force F into distance D. Okay. So force is defined by P1 A1 and distance D is defined by velocity and time. Remember, you have learned during your basic science course in school that velocity is nothing but distance divided by time. So you make the subject distance. So distance is equal to velocity into time. So that is why V1 into d tau. Here d tau is representing the time. Now, so the total work at inlet, or let's say at section 1, is how much? P1 A1 V1 d tau. Okay students. Next, mass flow rate. So mass flow rate is what? Rate of mass. That means mass with respect to time. Okay. So dm1 divided by time. So mass flow rate is also represented as area into velocity divided by specific volume. You have to remember this. Okay. If you put the unit of area, velocity and volume, and if you solve that, then its unit will be kg per second. And you can see on the left hand side, the unit will be kg per second. So that is how the mass flow rate is defined. Okay. This is another way of defining the mass flow rate. Here, capital A is area of cross section, capital V is velocity, and small v and in the denominator is representing the specific volume. Okay. Now the unit of capital A will be meter square, unit of capital V will be meter per second, and unit of small v will be meter cube per kg. Okay. Now flow work at inlet is equal to how much? So here, as you can see in this particular equation, let me erase other unnecessary terms. So as you can see, A1 V1. So I have defined the A1 V1 from this equation. So instead of A1 V1, what I can write? So in this particular second equation, if I make A1 V1 as a subject, then this small v1 will be multiplied on the other side, right? So I can write dm1 into v1 into d tau, right? So if I will put this value over here, then the final value will be p1 v1 dm1. I am repeating again, students, what I have done, I have replaced the value of capital A1 V1 from this equation into back this equation. Okay, so you can do that exercise by yourself also. Okay, now work transfer. Another work is shaft work. Shaft work is what? Simple. A motor is connected with the shaft, and if the shaft rotates, then the shaft work will be how much? So shaft work will be T d theta, where theta is what? Angle. Okay, so together it will be defined as d theta by d tau if you divide it by time, because angular revolution is occurring when the shaft will rotate. So it will be T omega. Okay, now same way heat transfer. Okay, now heat transfer is also a path function. Okay, so as you can see, for heat transfer, if I will plot temperature on the y-axis and another quantity on the x-axis, I am not defining this quantity. Let me tell you, we will study later on in the further courses that this x quantity is nothing but entropy. Okay, so if we plot y-axis with temperature and x-axis with the entropy, and if we plot any curvature on this TS diagram, then the area below that curvature will give us the heat transfer during that process. Okay, so that is why it is defined as Q is equal to integration of TdS. It is just like the work transfer, but in case of work transfer, the graph was what? Pressure versus volume, and in case of heat transfer, the graph is in the form of temperature versus entropy. Here again, you can prove that it is a path function. If you draw another line like this, that is for process 1 to 2. So you have two different lines. So, or you can say two different paths, right? So one path is having smaller area and the another path is having larger area. So heat transfer during both these two paths are different. Okay, so heat transfer is also a path function. Okay, and the functions which are not dependent on the path will be called as point function. Okay, now sensible heat and latent heat. Now amount of heat transfer required to cause phase change in unit mass of a substance at a constant pressure and temperature, that is called as latent heat. Very simple. What is latent heat? You want to convert 0 degree Celsius ice into 0 degree Celsius water. So you have to obviously supply heat. So that heat is called as latent heat. So for latent heat, you have not changed the temperature. You have changed the phase. What phase change has occurred? From solid to liquid. 0 degree Celsius ice to 0 degree Celsius water. Okay, so the formal definition will be like this: amount of heat transfer required to cause phase change in unit mass of a substance at constant pressure and temperature. At constant pressure and temperature means what? During the phase change, the pressure will be same and the temperature will be same. Okay. Now, latent heat can be referred with respect to solid to liquid and with respect to liquid to gas. So if you convert solid to liquid, then it will be called as latent heat of fusion. And if you convert liquid to gas, then it will be called as latent heat of vaporization. Same way, if you directly convert from solid to gas, then it will be called as latent heat of sublimation. Okay, so remember that. Very simple. Sensible heat means what? If you supply the heat and if the temperature of the substance changes, then it will be called as sensible heat. Next is specific heat. So specific heat is very simple. Let's say you want to raise the temperature of particular substance by 1 degree Celsius or 1 Kelvin. Then you have to obviously supply the heat. Okay, so that particular heat is called as specific heat. Here all the quantities are defined for single unit. Let's say the formal definition. Let's see the formal definition. The amount of heat required to raise the temperature of 1 kg of mass by 1 degree Celsius or 1 Kelvin is termed as specific heat of a substance. That means, let's say you have 1 kg of water at 20 degrees Celsius and you want to raise the temperature of 1 kg of water to 21 degrees Celsius. That amount of heat given to the water, that will be called as specific heat, because you have 1 kg of water and you have converted the temperature from 20 to 21 degrees Celsius. Okay, so that is simple. And here you should note and appreciate that 1 degree Celsius change or 1 Kelvin is same. Okay. Now the unit, for unit you may say that specific heat C is nothing but Q divided by M into delta T. So you have to remember the definition by this equation. If you remember this equation, then it will be easy to remember the definition. Let's see and read the definition again. Amount of heat required, that is Q, for unit mass, that is 1 kg of substance, and for raising the temperature by 1 degree Celsius or 1 Kelvin. Okay, so that is nothing but the specific heat. Okay, now in case of gas, there are two specific heats because gases are compressible. So specific heat at constant pressure and specific heat at constant volume. Okay, and in case of solid and liquid, there are only single value for specific heat. Okay, now remember, if you multiply mass by specific heat of any substance, then it will give the heat capacity of that particular substance. This is a very important term, remember.
Now, let us understand certain definitions. So, for understanding the definition, I have plotted PV diagram. So, I have taken pressure on the y-axis and taken volume on the x-axis. The very first definition is properties. So, what is the meaning of properties? So, in order to describe any physical condition of a substance, you will require certain characteristics. So, that characteristics are known as properties. For example, if you want to define the hotness or coldness of a substance, then you will require temperature. So that temperature is nothing but the property. Now, if the property has certain definite value, then it will be known as state, right? So as you can see on the PV diagram, I have plot one state. So particular to this cross mark, you will have a particular pressure value and you will have a particular volume value, right, on respectively y and x axis. Now, if any operation is done in which one or more than one property is getting changed, then it will be known as change of state. So if you are moving from this cross mark to this cross mark, then you can appreciate that the pressure and volume both will get changed. So both properties are changing. So that moving from first cross mark to the second cross mark, that will be known as change of state. Now further, path. So succession of change of state will be known as path. Now if the path is completely defined, so that will be known as process. So for your understanding, I have shown over here constant pressure process by a horizontal line. So path is completely defined, so that will be known as a particular process. For example, constant pressure process, constant volume process, then reversible adiabatic process, isentropic process, like that. And if the two or more processes are occurring such that the initial state is identical with the final state, then it will be known as cycle. So here you can see from 1 to 2 and from 2 to back to 1. So the initial and final state both are one number. So then this is known as cycle. Okay. So today we are keeping up to this point. Thank you.